Hey, if you're conducting a multiple comparisons test, that means that you have already done an ANOVA and the result was statistically significant, which automatically means that you did reject the null hypothesis. And so then you can do the multiple comparison test, which requires this Q table, student Q, and it is an HSD for the Tukey test or Tukey-Kramer test, which is on the formula sheet. So the HSD stands for honestly significant difference test. And we use the alpha of 0.05. So just to look at the formula sheet that we have in the course, and I'm just going to bring us down to the multiple comparison tests. Here it is right here. All right, so we have the Tukey test or the Tukey-Kramer test. So one way ANOVA is the HSD is equal to that Q. So that's the critical value Q that we need. We can calculate it this way. That's when all of the columns have the same length, if they're all equal, or you can use this part of the formula, which means they're different. That's why you have an n subscript I and an n subscript j. So that's when you would have used this part of the equation when the columns are not the same, or the size of each group is a different size. All right, so those Q's are what we want from the table. Those are the critical value. And so it's going to be the degrees of freedom. Just like the F distribution, there's two sets of degrees of freedom. The first number is the number of treatments. And the second number is the error degrees of freedom. And so we'll go over to our table and find a critical value. So the Q critical value would be, let's suppose we have, and then this is the number of treatments up here, populations, it would be across the column. So let's say we have 9 treatments, and let's suppose our mean square error degrees of freedom, so the degrees of freedom that correspond to the error from the ANOVA test, let's say it is 12. We would use the row and cross tabulate. So this would be a Q critical value with 9 and 12 degrees of freedom. And it's corresponding to an alpha threshold of 0.05 or 5%, which is the area that's equal to the area under the curve, which is the rejection region. And we get a value here. We're going to cross tabulate that to be 5.27. And so that is what is used in the formula on the formula sheet. So you would use 5.27 and you would just put that into the formula. And that's how you use the Q table for the HSD test, or in other words, it's called the multiple comparison test.